So we have a practice test right here, and the first half of the test of this practice test, 15 questions long, and it's all about simplifying radicals. Now notice that each of these radicals, most of them have variables. Anyway, there is not going to be 15 of them on the test. There's going to be 11 of them only. So this is going to be a little bit shorter on the actual test. But for the most part, everything else is pretty much the same. We're going to have 4 of these where you have to change them from radical form to exponential form, or vice versa. And we're going to have 5 of these where you solve the exponential equation by getting the same base and then solving the equation. Let's start with number 1. We need to remember that the square root of a negative number, the square root of a negative 1, is really the value of I. So we all know that the square root of negative 16 could be rewritten as negative 1 times 16, which means that when we split the root, we have negative 1 times the square root of 16, and 16 is a perfect square number. The answer is 4, and the square root of negative 1 is I. So we're going to multiply I times 4, which is equal to 4I. And that's the answer to number 1. That's it, 4I. But before we move on, I want to compare the square root of negative 16 to the cube root of a negative number. So let's compare that. Let me actually move it a little bit further to the side here. Let's compare it with the cube root of negative 8. The reason why I want to compare this right now is because when you have a square root of a negative number, you know you're going to get imaginary. And the reason for that is because when you think of a square root, you're thinking what value times itself will give you negative 16. So if you're thinking 4 times 4, that doesn't give you a negative 16. Not even negative 4 times negative 4, that doesn't give you a negative 16 either. There is no such number that when you square it, it'll give you a negative answer. So that's why it's imaginary. But over here, when you're thinking about cube roots, you're really asking yourself what times itself 3 times will give you a negative 8 as an answer. And the answer to that is negative 2. So that's not imaginary. That's the actual answer, negative 2. Think about it. What is negative 2 times negative 2 times negative 2? Well, negative 2 times negative 2 is positive 4, and positive 4 times negative 2, it really does give you negative 8. So the answer to the cube root of 8 is actually negative 2. You can do cube roots of negative numbers. You cannot do square roots of negative numbers. You end up with imaginary. Just to let you know. All right, let's move on. Number 2. So there's probably not enough space on this practice test for you guys to show all of your work. The very first process of dealing with a radical, a square root like this, is to split up the radical to each of the terms. So I would either write really small or rewrite it in a separate paper. 121 is the value in one square root. The square root of a to the 4th is a value in another one. And d to the 6th is also in its own square root. So again, I took the square root and I divided it up into each term, the 121, the a to the 4th, and the d to the 6th. Now, the square root of 121, that's awesome. That's 11. 11 squared is 121, so there's no more square root. And we need to remember that a square root is really the power of 1/2. So it's kind of like dividing this power by 2. So I already know my answer is going to be a to the 2nd. So a to the 2nd is my answer for that one. Now, if I wanted to be thorough and show all my work, I would show that the square root is really the power of 1/2. And then I would place my a to the 4th right in there. And then I would use the rule of exponents, that a power to a power you multiply. And when you multiply 4 times half, you're going to get a to the 4/2, 4 over 2. And again, that simply means 4 divided by 2, which is why we get a squared as the final answer. Do you need to show this work? No, you don't. As long as you understand that a square root is kind of like dividing the inside power by 2. A cube root would be kind of like dividing the inside power by 3. A 4th root would kind of be like dividing this inside power by 4. So keep that in mind. Let's move on to this next one. The square root, again, that's power of 1/2. It's kind of like dividing this power by 2. Okay, 6 times half is kind of like dividing 6 by 2, which is 3. So my answer will be d to the 3rd. So this is my final answer, guys. 11 times a squared times d to the 3rd. Just write it together. 11a squared d to the 3rd. And we're done. Let's move on. Again, you're going to have to show your work, and I recommend writing smaller or rewriting this on a separate sheet of paper. So let's split up that square root to each of the terms. Let's put the 45 underneath the 1 square root. Let's put the square root of t. Let's put the square root of u to the 5th. So as we can see, 45 is not a perfect square number. You want to rewrite it with multiplication to get a perfect square number. So what we're going to do is rewrite it as 9 times 5. 9 times 5 is 45. And when I split that root, the square root of 9 really is 3. And the square root of 5 is going to stay the square root of 5. How about this square root of t? Again, a square root is kind of like dividing the power by 2. But then again, there is no power here. It's an invisible 1. You can't divide 1 by 2. That's still 1/2. So let's not mess with it at all. Okay? If it were a square, like t squared, then it would just be t, because 2 divided by 2 is 1. But it's just t. You can't really divide it by 2. I'm just going to leave it. There's nothing to do. Bring it down, square root of t. Over here, we have the square root of u to the 5th. Now, it's kind of like the square root is kind of like dividing this power by 2. And notice that it's not divisible by 2. But I could rewrite it with multiplication to get a power that is divisible by 2. So I'm going to take this u to the 5th, and I'm going to rewrite it as u to the 4th times u to the 1. Because after all, u to the 4th times u to the 1 really does give me u to the 5th. So all I did was rewrite it. And the reason why I rewrote it is because the square root is a power of 1/2, which means I want it to be divisible by 2. 5 is not divisible by 2, but 4 is divisible by 2. So let's split that root to both terms. The square root of u to the 4th, 4 divided by 2, is 2. And the square root of u to the 1, that's just the square root of u. You can't really do it. Bring it down, the square root of u. This is our answer. But we just need to put it in order. Let's put the 3 and the u squared together. 3u squared. And then let's put all of these square roots together underneath one square root. The 5, the t, and the u. Put it underneath one square root. 5, t, and u. Ladies and gentlemen, this is our final simplified answer of number 3. Let's move on to number 4. Again, on all of these, you're going to end up splitting the radical. Even if it's not a square root, it could be a third root, a fourth root, split it up and deal with each item individually. So let's split that radical and put it on the 75. Split that radical, put it on the p to the 7th. And these are square roots, by the way, so we want to deal with perfect square numbers. And 75 is not a perfect square number. You want to rewrite it with multiplication to get a perfect square number. And I hope you remember that 25 is a perfect square number, and 25 times 3 gives you 75. So when you don't have what you want, you rewrite it with multiplication so you could get what you want. Again, you wanted a perfect square number. You didn't have it. Now that you rewrote it with multiplication, now you do have a perfect square number. So when we split the root, you'll have 5 square root of 3 as that part of the answer. And on the other one, we have a square root of p to the 7th. A square root is the power of 1/2, which means that we want this number to be divisible by 2, because the power of 1/2 is really, when you multiply 7 times half, it's really dividing 7 by 2. But the problem is 7 is not divisible by 2. So you want to rewrite it with multiplication to get something that's divisible by 2. Like over here, you didn't have a perfect square number. You rewrote it with multiplication so you could get a perfect square number. Over here, you have something that's not divisible by 2, and you're going to rewrite it with multiplication to get something that is divisible by 2. So I want to put p to the 6th times p to the 1. After all, 6 plus 1, it does give me 7. So I rewrote 7 as 6 and 1 on those powers. Now I'm going to split the root. And we said that the square root was kind of like dividing this power by 2. So 6 divided by 2 is 3. So I get an answer p to the 3rd. There's no more square root. And this square root of p to the 1, you can't really do it, so just bring it down, the square root of p. And it's really not necessary to put to the 1 power. We already know it's 1. So this is our answer. We just need to rearrange it. Let's put the nice values that are outside of the radicals first. 5 p to the 3rd. And then put this radical with this radical together underneath 1 square root, 3p. Ladies and gentlemen, this is it. I do want to caution you. I want you to be careful with something. notice that this 3 belongs to the p. It's p to the third. Make sure you don't put this 3 over more this way, because if it's right here, then the answer is going to say third root. So please be careful with the way you write your answers. Make sure they're clean. If this belongs to the p, make sure it's right here. If it's a root, make sure it's between these two sticks right here, this space right here. Okay. Number 5. Once again, let's break it all up. We're going to split the root to everything. The square root of 108. The square root of x to the 8th. The square root of y to the 6th. And the square root of z to the 9th. Okay, 108 is not a perfect square number. And to be honest with you, right now, I can't think off the top of my head the multiplication of a perfect square number. So I'm going to make a perfect square number list to help me. 4, 9, where am I getting this from? 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, and so on and so on. Now, I need to rewrite the 108, since it's not a perfect square number. I want to rewrite 108 as the multiplication of one of these numbers so I could get a perfect square number. So you could use calculators on this test. I would just go 108 divided by and try one of these. Maybe try 9. It does work with 9. 9 times 12 is 108. But take a couple more moments and try to divide 108 by 16. 108 on a calculator divided by 16. It doesn't work. Let me try 25. No, that's not going to work. 36. 36 divided by, 108 divided by 36. 108 divided by 36 on a calculator gives me 3, which means that I could rewrite this as 36 times 3. And that's great because 36 is a perfect square number. That's why we're rewriting it to be 36 times 3. That way when I split the root, I could actually do the square root of 36, which gives me 6. And the square root of 3 is going to stay the square root of 3. Moving on. A square root is really the power of half. So that's kind of like dividing this power of 8 by 2. So I'm going to end up with the answer x to the 4th, because 8 divided by 2 is 4. Same concept here. The square root is really the power of half, which is kind of like dividing 6 by 2, which will give me y to the 3rd. And last but not least, the square root of z to the 9th. It's kind of like dividing this power by 2, but you see the problem is 9 is not divisible by 2. I want something divisible by 2 right here. I want a power that's divisible by 2, so I am going to rewrite it with multiplication as z to the 8th times z to the 1. Right? Z to the 8th times z to the 1, it's really z to the 9th. So I rewrote it because now this one is divisible by 2. So when I split the root, I will be able to say that z to the 8th with the square root is really dividing the 8 by 2, and I will get z to the 4th. Z to the 4th. And the square root of z to the 1, that's simply going to stay the square root of z to the 1, but you don't have to put to the 1 power. So this is all our answer. We just need to organize it. Let's put the nice values out front. The 6, the x to the 4th, the y to the 3rd, the z to the 4th. 6, x to the 4th, y to the 3rd, z to the 4th. And then let's put our radical values, the square root of 3 and the square root of z. Let's put them together underneath one radical, one square root, 3 and z together. That is your final answer for, what is this, number 5. Let's jump to number 6. On number 6, we need to remember that we're able to split any radical. When you have a fraction on the inside, you're able to split the radical to the top and to the bottom. It doesn't matter if it's a square root, third root, any type of root, you could split it and put the root on the top and put the root on the bottom. That's exactly what we're going to do. We're going to split it, square root of 20, square root of b squared. So this one problem, it kind of becomes two problems. So let's work on the square root of 20. If I were to work on the square root of 20 right here on the side, it's not a perfect square number. I want to rewrite it with multiplication to get a perfect square number. And 4 is a perfect square number. Obviously, I wouldn't rewrite it as 2 times 10 because neither of those are perfect squares. The square root of 4 is 2, and the square root of 5 stays the square root of 5. So the square root of 20 above is going to become 2 square root of 5. So let me rewrite the top, the numerator. Let me rewrite it as 2 square root of 5. And the denominator, what is the square root of b squared, that's simply b. Okay, so on the bottom, I'm going to put a b. If you're wondering, like, well, why is this equal to just b? Well, remember, the square root is really like the power of 1/2, which would be dividing this power by 2. 2 divided by 2 is 1, but it's unnecessary to put the 1. Or you could also think of a square root is the exact inverse of squaring. So the square root and the square eliminate themselves, and you just have a b left over. Anyways, that's your answer. There's nothing else to do. And when it comes to getting answers that have fractions with radicals, you don't want to leave a radical in the denominator, and there is no denominator with a radical in this answer. So there's no radical in the denominator on this answer, so we're good. Let's move on to number 7. 7's a little different because same process, we're going to split the root, put it on the q, split the root, put it on 32. So when we think, what's the square root of q? Well, the square root of q is the square root of q. You can't do anything with that. But the square root of 32, you could actually do that, square root of 32. 32 is not a perfect square number, so you could rewrite it with multiplication to get a perfect square number. Now, some of us jump on the very first perfect square number, 4. 4 times 8 is 32, but that's not the best thing to do. Take a couple of moments more and think of a higher perfect square number. Instead of 4, try 9. Will 9 times something give you 32? No. How about the next perfect square number, 16? Will 16 times something give you 32? Absolutely. 16 times 2 gives you 32. So when you split the root right here, you will end up with 4 square root of 2. So the denominator, square root of 32, we're going to rewrite it in its simplified form, which is 4 square root of 2. So let me rewrite my entire equation. This guy right here, let me rewrite it right below. It's going to have the square root of q, and on the bottom it's going to have 4 square root of 2. Now, if you leave this as your answer, it's technically not completely right because you need to get rid of this radical in the denominator. And whenever you want to get rid of a square root, you have to multiply it with itself. Because we should all know by now that when you multiply the square root of 2 with the square root of 2, you just end up with 2. Okay? And what you do to the bottom, you must do to the top. Now the reasoning for that, square root of 2 times square root of 2, that gives you the square root of 4. And the square root of 4 takes you back to the answer 2. So up on top, the square root of q times the square root of 2, we could multiply those together and put them underneath 1 square root. So my answer on top will be the square root of 2 with a q, 2 times q. And on the bottom, we have this original 4, there it is, and we said that the square root of 2 times the square root of 2 was just 2. So on the bottom, I really have 4 times 2. So my answer, my final answer, is going to be the square root of 2q over 8. That's my final answer for number 7. This one required more work than the previous one because we actually had a radical, a square root in the denominator. Number 8, another one where we split the root. So we're going to split the root up here. It'll be 25ab, and on the bottom it's going to be 16 a to the 6th b. So again, you have one problem, and now it's kind of like having two problems that you're going to do. So let me do the top one. When I do the square root of 25ab, I'm going to split the root. So if I put the square root of 25, the square root of a, and the square root of b, and then I do whatever I can, the square root of 25 is 5, and the square root of a, you can't do anything with it, bring it down, and the square root of b, you can't do anything, bring it down. Now, if this were my only problem that I were doing, I would put it together and say that my answer is 5 square root of a, b, underneath 1 square root. But because I know I have a denominator, I'm just going to leave them separate for a little while. And if for some reason nothing cancels out, then I will put these guys together at the very end. But anyway, this is what we have up on top. Let me rewrite it up there. We have 5, the square root of a, and the square root of b. Now on the bottom, let's do the bottom one now. We have the square root of 16 a to the 6th b. So let's split up the root. We're going to have the square root of 16, the square root of a to the 6th, and the square root of b. And we all know that the square root of 16 is 4. And we all should remember that the square root is really the power of 1/2, which is kind of like dividing this power by 2, 6 divided by 2 is 3. So I will have a to the 3. And the square root of b, I can't do anything with it, so I'm just going to bring it down square root of b. So this is my new denominator in simplified form. So I'm going to replace the original denominator with this new denominator, 4a to the 3rd square root of b. Now you're probably thinking, well, I don't want this square root of b, so I'm going to multiply both top and bottom by the square root of b. However, if you have something on top and the other exact same thing on the bottom, you could just cancel it out. So might as well do that. Cancel, cancel. And ladies and gentlemen, that is your answer. Let me rewrite it down here. 5 square root of a over 4, let me get more space, a to the 3rd. And that's it. This is your answer. There is no radical on the bottom. There's nothing else to simplify. Like if this would have been an 8, yeah, 8 over 4, you could cancel it out, reduce it. But there's nothing else to do. You definitely can't cancel this square root of a with this a to the 3rd because they're not the same exact value. This is a radical. This is a nice a to the 3rd. So that's it. Let's try number 9. If you're thinking, oh, we're going to have an imaginary answer here because of this negative sign, that's wrong. Why? Because this is not a square root. This is a cube root. And remember, you can do the cube root of negative numbers, right? It's really asking yourself, what times itself 3 times will give you negative 27? So let me first split the 3rd root. Let's put the 3rd root on the negative 27. Let's put the 3rd root on the x to the 3rd. So again, what it's asking for is what times itself 3 times will give you a negative 27. The answer to that is negative 3, no more root. I mean, think about it. What is, let me just do my work right here on top. What's negative 3 times negative 3? That's positive 9. Times negative 3, that's negative 9. I mean, negative 27. I'm sorry. Yeah, negative 27. So, the cube root of negative 27 is negative 3. Now, how about over here? The cube root, not the square root, the cube root is exactly the 1/3 power. And the 1/3 power is really like dividing this exponent by 3. Okay, so what is 3 divided by 3? It's just x. So your answer is negative 3x. That's your answer to number 9. Let's jump to number 10. Again, another 3rd root. Let's split it. So we have the 3rd root of 32. We have the 3rd root of n to the 4th. And 32 is not a perfect cube number. So you might want to write down or jot down your perfect cube number list to help you out here, because we want a perfect cube number. So 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. And you know what? It has to be 8, because 27 times 2 is way bigger than 32. So 8 times what is 32? 8 times 4 is 32. Again, what I'm doing here is, since it's a cube root, I want a perfect cube number, and this is not a perfect cube number, so I am going to rewrite it with multiplication to get a perfect cube number, in this case 8. 8 times 4 is 32. And when I split the root, and I'm talking about 3rd roots here, I could actually do the 3rd root of 8. The 3rd root of 8 is the nice, beautiful number 2. Now the 3rd root of 4, you can't really do that, so just bring it down. So you really have 2 times the 3rd root of 4. And over here, the 3rd root really is the 1/3 power, which is kind of like dividing this power by 3. So you want something divisible by 3. And 4 divided by 3 doesn't work. It'd be nice if this were a 6. 6 divided by 3 would be 2. But it's not. It's 4. So I need to rewrite this end of the 4th to change this number to be something that is divisible by 3. Sometimes you can't do it, but in this case you can. You could rewrite end of the 4th as n to the 3rd times n to the 1, because 3 plus 1 is really 4. So we're rewriting it as n to the 3rd times n to the 1. And we're going to split the 3rd root to each of them. And of course, the 3rd root of n to the 3rd, that's like 3 divided by 3, that's just n to the 1, but I'm just going to write n. And the other one, you can't really do anything with it, so simply bring down the 3rd root of n. You don't have to put to the 1. So this is our answer. We just need to rearrange it. Okay, so let's put the nice values out front, the 2 and the n, put those out front. And then take the cube root of 4 and the cube root of n and put those together underneath one single cube root. 4n. We are done. Moving on. Number 11. Number 11. I keep getting tricked by this guy all the time. First of all, we want to understand that this is saying -3 times. So this right here is just the multiplication of -3. It is not -3 to the third power. That 3, I don't know why the computer does it, but it should be a little bit closer this way between these two in this area. This is saying the third root. Anyway, let's not forget that at the very end, we're going to end up multiplying by -3. Whatever our answer is, whatever we have on the outside, we're going to multiply it by -3. So let's just put that -3 on pause, and let's focus in on the cube root of 256xy to the 9th. So just like any other root, whether it's cube or squared or the fourth root, whatever root you have, let's split it up to each of the terms. So I'm going to put the cube root of 256. I'm going to put the cube root of x and the cube root of y to the 9th. Okay, so 256 is not a perfect cube number, or is it? I'm not sure. I'm going to make a perfect square number list, all right? 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. So we need to rewrite this number as one of these numbers, but being multiplied with something else. Okay, so you don't have a perfect cube number. You want to rewrite it with multiplication to get a perfect cube number. So the best way to tackle this is to get your calculator and just say 256 divided by, try 64, right? 256 divided by 64, and luckily it gives me 4. So I know that 64 times 4 will give me 256. If 64 wouldn't have worked, then I would have tried dividing it by 27, then tried dividing it by 8, right? But it did work, so now we're able to split the root, the third root that is. And now that I have the cube root of a perfect cube number, I'm able to do that. What do I get? I get 4, because 4 times 4 times 4 is 64. There's no more root on it. You bring down the cube root of 4, and that's the first answer that we have for this first part of the problem. We have 2 more parts to deal with. And if you take a look at this next one, there's nothing to do there. The cube root of x is exactly that, the cube root of x. Can't do anything with it, cube root of x. Now this other one's nice because the third root is really the 1/3 power, which is kind of like dividing this power by 3. And it is divisible by 3, so it's nice and easy. The answer is y to the third. Okay, you don't have to show your work, but if you wanted to, you could say, okay, I'm going to rewrite this as to the 1/3 power, and inside there I have y to the 9th, and when I multiply 9 times 1/3, I'll get y to the 9 divided by 3, 9/3, and 9 divided by 3 is 3. Anyways, again, you don't have to show this work. You just need to remember that the power ends up getting divided by 3. So let's go back and look at our answer so far. Wow, I almost forgot about this -3. Yeah, this -3 is very important. So let's take this -3 and let's put it out here right in front of that 4. So -3 times 4, that is -12. And what other item is nice to write down? Well, we have this also, this y to the third. So -12 y to the third. And everything else is going to go inside the radical. So inside the radical, I have 4 and x. Ladies and gentlemen, that is our answer to number 11. Moving on to number 12. Actually, before moving on to number 12, I'm realizing that this video is very, very long. We've already done about half of the practice test here, and I'm going to do the other half on a different video.